Good afternoon, everybody. So I hear that Baltimore is getting some more snow. The snow, I heard 5 to 8 inches tomorrow and then another inch on Friday, but I can still drive home, so I'll be there next week. Just to give you an update on where we are. Let's see, today we're gonna review. Then on Monday, I'm gonna go on to the next chapter 2 and we'll do some notes online. And then Tuesday, you guys come in and take your test for chapter 1. So that way, I think first of all, I can proctor the test properly, but also it'll give you guys a chance to really study for the test. And, if you have any particular questions, that's when you guys will have a little bit more time, I think, to figure out what's going on. All right, so as far as the test goes, just so you know, let me share my screen. There we go. All right, come on, guys, put your cameras on. Need to see your faces. That way I know if you're confused or not. Grady, Matthew, Dylan. Thank you. Awesome. I would assume it makes it a better experience for you all too, right? Because then you can see other people. It's almost like being in a classroom, right? And I love when you guys raise your hands. That's great. That's even better. It makes it even more like a real classroom, right? All right, so first of all, you're welcome. I made an awesome test review for you. I mean, I went through and thought about all the questions and even went through my chapter 1 test from last year and looked at where, the kinds of things that were confusing them. So I made up this sheet. It's a test review, but I think that where students make their biggest mistakes is not knowing which formula to use when. So I made this great sheet for you, which will greatly improve your success on the test. I'm confident. So first, for the test, I will let you use a 3x5 index card. So if there's one thing or two things or three things that you're like always messing up, you can do that. Has to be handwritten in your handwriting, okay? No typed and then reduced to a smaller size. Trust me, I was in college too. I did that too, but I want this to be your work, okay? And the great thing about making an index card is you synthesize the information and get it in there, right? And down to such small things that you'll think of it like a little thing that you put on your card, and that to you, that's like synthesizing all that information in there. So I want it to be your handwriting. And you can do both sides. I'm not trying to torture you by making it a small index card. It's that synthesizing act that I want you to encourage to do, because when you're doing that and you're trying to put a bunch of stuff in your brain, if you can fit it to a 3x5 card, both sides, you've learned it. You've learned it. That's just a little bit of details that you might forget. All right. And this is a good habit to get into. It's something that when I was in college, I always did index cards. And I remember my boyfriend at the time, he would be like, I don't know how you do all that work. And then the index cards, I would leave them at home. I'd finish writing the index cards and I'd have like, I don't know, depends on how big the test was, like let's say 25 index cards, both sides, just synthesizing the information, big stack of cards. I'd leave them behind in my dorm room, go take my test and ace it. By the way, I'm a 4.0 GPA. So I always did well, and I wasn't necessarily crazy smart or any of that. I just learned how to study my freshman year, just because I had a really good roommate who did the same sort of thing. So learn from that. Remember, you're synthesizing the information, even if you never use the index cards again. Throw them away after the test. Although they're good when it comes to studying for a final exam too. Okay, so I made this first thing for you. How do you know which formula to use? There's three basic formulas, okay? One is linear. We learned a lot about that in sections 1.1 and 1.2, okay? Things that you need to remember is that the b, the y-intercept, is always going to be the initial value. So if they're asking you questions, remember b is the initial value. And m, of course, is the rate of change. Now, average rate of change or average rate of change it's really important for you to remember that this is the same thing as the slope, right? Which has the formula, oops, y, m, oops, let's make it legible. M is equal to y2 minus y1 over x2 minus x1. In your textbook, they give you another thing that means exactly the same thing as slope, right? The average rate of change is slope. So if they give you 2 points, then label one y1, y2, x1, x2, and then just put them in the formula. Okay, so there's 3 types of formulas. Sections basically 1.1 and 1.2 cover pretty much linear, right? And that is governed by this equation, okay? Now, if you want to know, like, when would I use a linear, is when the growth or the decay or the rate is a constant number, okay? It's not a percentage, right? Constant number, not a percentage. Well, let's just do this. Okay. And things like this, statements like this, the growth or decays, statements like this, something increases by, notice that this is a constant number, right? By 55 people or by a constant dollar value, right? It's an actual number. Okay, and then there would be 2 types of exponential formulas, okay? One would be a constant percentage, and the other one would be a continuous percentage. So let's take a look at the constant percentage. The constant percentage, right, is this one, which also is annual percentage rate, right? Annual as opposed to continuous. So an annual percentage problem would use this formula. Now, not all the problems, I'm going to have you pick what formula to use. Some of them I'll give you which formula you're going to use on the test, but some I will not, okay? So we've got, by definition, here's your formula. The growth or decay is a constant percentage where A is equal to 1 plus the growth rate or 1 minus the decay rate, depending on whether you have a growth or decay function. So for example, if A is equal to 1.19, and you know that 1.19 is equal to the growth rate. And this is for growth. For decay, you know that, let's say, for example, if we had A is equal to 0.987, then you know that 0.013 is equal to your decay rate, or equal to, what is that, 1.3% is decay rate. And note, all you would have to do is take 1 and minus your A value to find the decay rate. But note, of course, that 1 minus 0.013 does give you your A value. So that's why you can say that the A value is going to be 1 minus the decay rate. So it's a little different when you have a decay rate. It's also easy to spot a decay function because the A value is less than 1, right? So these are the kinds of phrases that you would see in a problem where you're using this exponential constant percentage problem, where they say annual percentage growth. Notice that this is a constant percentage, right? Constant 6%, not continuous, but constant. This is a constant interest of 4.3%. And then anything that says annual is going to be this formula. So this is just repeating this kind of stuff up here. But annual percent decrease, it would like of 5% or something. Or if you're reducing by a constant percentage. See, some people are still writing this. Let me let you catch up. Come on, Connor, turn your cameras on. I want to see your faces. Come on. Okay, so that's the P sub 0 A to the T power, right? Annual, but it's still a percentage. Then we go to exponential, where it's a continuous percentage. That's when we move to this formula here, P sub 0 E to the KT power. So P sub 0 is the initial value, right? Just like B is the initial value for linear, right? P sub 0 is always your initial value, and E to the K is the actual growth factor. So the growth or decay is a continuous percentage, where A would equal E to the K, right? And when they're talking about A here, they're talking about this A right here. So what's different when it's a constant percentage is it's just A here. When it's a continuous, your A is equal to E to the K, right? So this part of the formula, which is an A in exponential constant percentage, it's an E to the K. So the formula just changes by that, and that's it. What I want to say, and then this part right here where it says K is equal to the natural log of N, I want to show you how I'm getting that, but it is a nice shortcut to know that. So let's take this A equals E to the K power. And let's say I'm going to take the natural log of both sides. Oops. I want to put this in the right color so you understand what I'm doing. Well, remember, when you're taking the natural log, the two E's together, right? The E is implied there, right? That's just the base. And whenever you get this, you get to just drop the whole thing, and that's how you're going to get K is equal to the natural log of whatever A is. So this is kind of a cool shortcut if you're doing some algebra. So all these kinds of problems, the one thing that I would be careful about is population, because if they said that population was growing by 5% each year, that would be more like constant percentage, right? So be careful. You're looking for the word continuous. So I think I would get rid of this word right here, because not all population problems are continuous. But all the double or half-life problems will be continuous, and any present or future value problems will have these formulas here. You like that, Paige? I worked hard on that for you guys. Does that help you? Yeah, good. Okay, so now for the rest of this review, what I have are some problems that we're going to practice together. Now, these problems do not make up the entire Chapter 1 test, Okay, the chapter 1 test is based on all the notes and all the homework. This review is meant to be about 75% of what's going to be on the test. Okay, so if you nail this review and you study really hard, you could probably get a 75. But you're going to have to do more than that, right? You're going to have to go back through the notes, go back through homework problems that you missed, maybe ask for a meeting. Yeah, Jadelle?
So I was wondering for like the past assignments, is there any way you can like, I don't know if Riley will allow you to do this, but like kind of show what we got wrong, like kind of give us like the solution to like, cause you know, after 3 tries, it's absolutely wrong. So is there any way like you can like show the solutions of like how is right or something like that?
I can. I hesitate to do that because only one person needs to do that and then can share that with the rest of the class. And that's what worries me about that. But Jadelle, you and I have met, right? And I've cleared something up for you real quick, right? We've met maybe 10 minutes, a couple different times, and it cleared it right up for you. And I hope that I've been available for you to ask those sort of questions. So if you get to that point, I'd really like for you and I to get together so that I can explain it. Can we continue in that way? I'm available for you. All you guys do, a couple of people called me. That's perfectly fine. You can text me, hey, can we meet for 5 minutes or 10 minutes or whatever? I'm completely available for you guys. Is that
Oh,
a
yeah,
reasonable
that's
answer?
fine.
Okay.
Yeah, that's fine.
Okay, great. Thank you. All right.
I have a
So
question.
let's see, who is that?
Drew.
Oh, sorry, Drew, your name is a little bit cut off. Let me see if I can move this
Okay.
up. Oh, now I can see
What's
it.
the name? What's the name of the YouTube video that you post the classes on, or the YouTube that you like post the videos on?
Okay, let me show you where it is. Let's see. Let me pull this down for a minute. So this is my class. This is what you kind of see, right? Your student view. Here's course syllabus, course pacing guide, help, Zoom class meeting recordings. So you hit that and it'll take you right to my YouTube channel.
Okay, thank you.
You're welcome. I would bet that a lot of people were wondering about that. Thanks for asking that question, Drew. Okay, so let's do a couple problems together. All right, this first one is from section 1.2. I think this is a typo. Get rid of this. Oh, where? No, it's not. Where T is. Yeah, let's make that italic. There we go. Okay, so let W equals F of T represent wheat production in Argentina in millions of metric tons, where T is the years since 2010. And that's kind of going to be the MO on the test, where I give you a lot of problems like where T is years since a certain year, okay? Interpret the statement F of 5 is equal to 49.2 in terms of wheat production. So in what year are we talking about here? Remember, we're talking about years since 2010.
2015.
Yes, 2015, right? Because notice that this T means time. And that's years since 2010. So F of time is equal to 49.2. So Argentina produced how many million metric tons of wheat, obviously?
49.2.
So simple, that's like from section 1.2, I believe. All right, here's another good one. This would be from section 1.3. All right, this is kind of a gross problem. I must have just been like, oh, that's a good problem. But if you look at what it's about, it's disgusting. The solid waste generated. I think I would have changed that if I realized what the problem was about. That's so gross. Anyway, the solid waste generated each year in the cities of the US is increasing. The solid waste generated in millions of tons was 238.3 in 2000 and 251.3, I'm sure this is in thousands, in 2006. Assuming that the amount of solid waste generated by US cities is a linear function of time. This is important, guys. This means you're going to use what formula?
Y max plus B.
Yeah, absolutely. Okay, find a formula for this function by finding the equation of the line. There's another hint through these. Here's another hint, 2 points, right? They're giving you 2 points. So 1 point is, let's see, X1 would be in 2000. Y1, the amount that goes with that is 238.3. And then the other X2, or the time that they're giving us, is 2006. And 251.3 would be your Y2. So this is linear. So the first thing we need to do is figure out the slope, right? So this is just slope formula. Y2 minus Y1 over X2 minus X1. So we have 251.3 minus 238.3 all over 2006 minus 2000. You could also say 6 minus 0. Get the same thing, right? So you would get 13 over 6. Okay, so now what I'm going to do is plug in let's say Y. Let's pick a point. Let's pick Y1 and X1, and I'm choosing those points because they're easy, right? Because 1 is 0. So I'm going to say Y1 is equal to 13.6, and we found that with the slope formula. So we got 13.6, and now let's use X1 plus B. So and you could choose any point you want. I'm just going to choose that one because it's a little easier. So Y1 is 238.3 equals 13.6x. Oops, and we know what x is, which is 0, plus B. So what we get here is 13.6 times 0 is just 0, so that gives us our B value, which is equal to 238.3. Which should make sense to you. We've got Y equals 13.6x plus 238.3. Now remember what I said earlier when I was talking about linear graphs, is this is your initial value, right? And that's what it is, right? We're talking about the earliest time is 2000. So initially, the amount of waste was 238.3 probably. Oh, it's in millions of tons. Yeah, millions of tons. So that's your initial value, right? And then this, of course, is your slope. So you found a formula for this function. Here's your formula. Now you're going to use your formula to predict the amount of solid waste generated in 2020. So 2020 minus 2000 is equal to 20 years. So what you're trying to find here is when the X value is equal to 20. So we've got Y equals 13, 6, 20 plus 238.3. And then you can just put the whole thing in your calculator at once. You get that.
Wait, on the test, we're allowed to use a calculator?
Yeah, absolutely. Any questions? Okay, so that's pretty much the linear stuff, right? Let's see. This is also average rate of change. What did I tell you? Average rate of change is the same thing as what again?
Slope.
Thank you. Okay, so we're supposed to calculate the slope at each of the 4 quarters in the table. So the first quarter, so first quarter 1 would be equal to 1481 minus 1467 divided by 0.25 minus 0. If you calculated that, you would get 0.56. So in this first quarter, we have 0.56. And then the next quarter would be calculated by taking 14.81. No, that's wrong. Sorry. 14.84, subtracting 14.81 and dividing. So I'm just using slope, like 0.5 minus 0.25. And if you calculated that, you would get 0.12. So that's the second quarter. And then if you calculate, I'm not going to do the other two, but I will color them for you. Quarter 3, you would get negative 1.16. And quarter, let's see, negative 1 point. And then quarter 4, you would get negative 0.68. So here they say that economists often say that an economy is in recession if the GDP, gross domestic product, decreases for 2 quarters in a row. Was the US in recession in 2008, do you think? Let me show you the years here. How would you answer that question? It's a yes or no question.
Yes,
Yes, and tell me why, Richard.
because the GDP decreases.
In the 2 quarters, right?
Yeah, the quarters.
It's decreasing in 2 quarters, so yes. So that was problem set from 1.3. Any questions? Anybody still need a minute? We good? Thomas, Grady, Tom, come on, come back. Okay, so this is a wolves problem. Wolves were once common in Western US, but by 1990, the population in Wyoming wiped out by hunters and wolves were put on the endangered species list. This happens a lot. In 1995, wolves were then reintroduced to Wyoming from Canada, starting with 14 wolves. And I want to point out to you that they already gave you the formula they want you to use. So starting, where is that? Starting with 14 wolves. So that's your initial value, right? Their number increased to 207. So that's the result of what happened, right? So the result is going to be P. Now we also know something about T. So here we've got T years after 1995. Well, if you take 2012 and subtract 1995, you're going to get 17 years, which is equal to T. And remember, what they're asking you for is they want to know what the annual percent growth rate is, which is the A value, right? Or you can find it within the A value, I should say. All right, so starting with P equals P sub 0 A to the T power, filling in what we know, 207 is equal to 14 A to the 17th power. So now we just have to solve that equation. So we're going to isolate A. So first thing we should do is get rid of that 14. We're going to divide both sides by 14. So you get 207 divided by 14. I'm not going to bother getting the decimal approximation because I know I've got more to do with that. Equals A to the 17th power. Now how can I get rid of that 17th power? Anybody remember?
If you took the log of both sides, wouldn't like add out?
Well, you could do two things. You could either raise this to the 1 over 17th power, same thing here. Or you could take the 17th power of both sides, right? So what we know about this is this cancels out, right? So you're just left with the A. And then this value right here would give you 1.172. That's the A value. Now remember, they're after the growth rate. So the A value is equal to 1 plus the growth rate. Oops. Spell it right. So A is equal to 1 plus 0.172, right? So the growth rate is going to be a percentage. So we're going to have 17.2%. Not 17, sorry. Yeah, no, that's right, 17.2 growth rate. Any questions? All right. Okay, this is an interesting and true scenario. The island of Manhattan sold for $24 in 1626. Imagine that, 24 bucks. Suppose the money had been invested in an account which compounded interest continuously. So what formula are we going to use for this? There's one of three, right?
Would it be the continuous percentage formula?
Yeah, of course. Thank you, Matt. All right, so we've got P equals P sub 0 e to the RT power. All right, let's see, what do we know? We don't know the result, right? Because that's what they're asking us for. The result is how much money would be in the account, right? Do we know the initial amount?
Would it be 24?
Yes, it would, Tom. Very good. We've got 24 E. Do we know the rate?
%5.
Yeah, and how do we put that in? Do we just put it in as 5 or
0.05.
0.05? Good. And what about the time? Do we know how many years we're talking about? Or do you know how to calculate how many years we're talking about?
2014 minus 1626.
That ends up being 388 years, which is your T value. Okay, so what should we do from here to get a value? Remember, E is just a number. So don't we have numbers on the whole right side? So from here, you can just put it in your calculator. There's no solving to do, right? E is a number. So P is equal to 6,390,343,320. Wow, imagine that. Or you could say 6.39 billion. So how would you set this up if instead of the rate being 5%, we're going to up it, let's say it's 6%, and they're asking you this time for the year that it would be worth $1 billion. Let's start with the formula first. E equals P sub 0 ERT. Do we know the result? Do we know how much we want it to be worth in this problem? We do. What do we want it to be worth? We're interested in when it's worth $1 billion, right? Do we have an initial value still? They just gave it to you earlier. What's the initial value again?
24.
24 E. Now we have 0.06 rate, and what we're trying to find is T, right? In what year, right? This is time. That's our variable now. All right, so now we actually have to solve this equation. So what's the first step, do you think?
Divide the 24 out.
Yeah, let's divide both sides by 24. And in this case, I did divide it out. You don't have to. There are 6 sixes. 1, 2, 3, 4, 5, 6.67. I even rounded it a little bit, knowing we're talking about years, so it's okay. So these cancel, and I have e to the 0.06 t power. Now what do we do?
Take log of both sides.
Right, so we'll have natural log of 41. Okay. So remember, when we have the base for natural log is always e, right? So when you have that scenario, then you just can get rid of the natural log, because natural log of e is just equal to 1, and 1 times that. So that works out. So we get 0.06t is equal to this number, natural log of this, divide both sides by 0.06. Oops, let's make it legible, sorry. And you'll get your answer. T is equal to 2.292.42 years. But they're asking you in what year, right? And this is, I teach SAT prep also, and this is one of the questions that they get people on. So let's see, our initial year was back in 1626, right? So if you do 1626 plus 292.42 years, you would be, what is that? I didn't even do it. 42, 8, 11. So remember, here it was worth over 6 billion. See you later. So it makes sense that it would be earlier, right, in an earlier year. So here's my question to you, and this the SAT does this too. Would it be 1918 or would it be in 1919? In what year?
1919.
Yeah, absolutely. And you wouldn't think so because you'd think you'd round down since you've got 0.4, but you have to remember that this is 1918 plus more time into the next year. Which is equal, the next year after 1918 is actually 1919. So very good, Drew.
Thank you.
Not that I'm trying to trick you. I'm not trying to trick you. The SAT tries to trick you by asking you those tricky questions. If you said 1918.42, I would take that answer. I just thought it was interesting. I was doing problems like this, and it's a common trick. And of course, in the multiple choice on the SAT, guess what? They'll have 1918 and they'll have 1919. And then everybody thinks, oh, this rounds down to 1918 and gives the wrong answer. But the SAT tries to mess with you. I'm not trying to mess with you. Okay. All right, so this was, what section was this? This was 1.8. And notice on 1.5, 1.6, 1.7, that's all about log stuff. So that's all that log stuff comes into play in all these problems. So I'm not gonna, I'm gonna cover that stuff, but in context for the rest of the chapter. So like taking the log of both sides, we already covered those. Okay, so this was section 1.8, which is all about moving a graph around the coordinate plane. Notice that here it says, use the graph of y equals f of x, which is there, to graph the function of this new function. So if you have something going on inside a function, you know that it's horizontal movement. And it's always the opposite way you think it would go. So you'd think if it was +1, that it would go to the right one, but it doesn't do that. It does the opposite. So it's going to go left. The entire graph will go left 1 unit. You're going to take each problem, each point, and go left 1 unit. So this would be the new one. Well, actually, let me use the color for the new one. So that's left 1. This is left 1. Left 1, left 1, and left 1. So this would be the horizontal movement. And then this would be the vertical movement. And this is up and down, or yeah, vertical means up and down, so vertical. And this is because it's outside the function. And it is what you think it would do. So it does move the graph down 2 units. So we're going to take our red graph and move that down 2 units. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So there is your finished graph. Questions? All right. Then here, what we got going on is this is a negative. So this is going to flip the graph over the x-axis. Oops. Sorry, I'm going to make this legible. Okay, so if we flip this over the x-axis, this point's going to stay where it is. This point is going to move down here and so on, right? So if you flip the whole graph over the x-axis, you're going to get this graph. And then this is, again, outside the function. So it is vertical. So the graph is going to just go up 3. So 1, 2, let's see, 1, 2, 3, 1, 2, 3, 1, 2, 3, and any questions? That's pretty self-explanatory, right? Yeah. All right, cool. Let's continue. So when we talked about supply and demand, I wanted to put this in the review because I didn't want you to think that supply and demand is always exponential, right? Sometimes it is constant, right? Or linear. So we've got a sporting goods wholesaler finds that when the price of the product is $20, let's go ahead and name these. The company sells 660 units. And when the price is $30, the number of sold decreases to 590 units. Oops, that's an X, make this a Y. So it says find the demand Q as a function of price P, assuming that the demand curve is linear. So I'm going to start with Y equals MX plus B. And I can, since I'm specifically saying Q and P, I'm going to put those letters in at the end. So I know that I have to find slope. So I'm going to do 590 minus 660 over 30 minus 20 to get the slope of -7. And notice that they do say it decreases, so that jives, right? So now we have Y. Let's take Y2 and X2. So I'm going to say Y2 is equal to -7. X2 is $30 plus B. Oops, I need to fill in. I'll show you where I'm getting this, sorry. So this would be X2 plus B. So now I'm going to fill in my X2, which is 590, and my I mean, my y2, which is 590, and my x2, which is 30. So if you solve that, you would get b is equal to 800. So now let's write our final equation, which would be y equals negative 7x plus 800. But we want it in terms of Q and P. So we're going to write the demand as a function of price. So demand is Q as a function of price is going to be equal to negative 7. Now remember, if it's a function of price, then that's our variable, plus 800. So that's just another one, writing something from linear. Now here it says, use your answer. This is 1.9, by the way. Use your answer to part A to write revenue as a function of price. Well, revenue, I like to use green for revenue. Revenue is equal to what times what? What's the formula for revenue? How would you figure out what revenue is? Something times something else.
Price times quantity.
Absolutely, Felipe, good. Price times quantity. All right, and we want revenue as a function of price, meaning we don't want two variables, we just want one variable. So what we're going to do here is use what we know about price. Well, price is the formula negative 7p plus 800. And oops, that would be price P times Q. Sorry, that's not correct. Okay, so price is just price, right? And Q of P is equal to negative 7p plus 800. So if you simplify that, you get revenue in terms of price is equal to negative 7p squared plus 800p. Is it cold today in Baltimore? Can you like smell that the snow is coming? You know that one smell that you get, it gets like, I don't know, it's like a clean smell in the air, the way you can tell, like, yep, it's coming. It's supposed to snow all day tomorrow too for you guys. All right, everybody good to go on? Any questions on this? All right, so here, the figure below shows the cost and revenue functions of a product. First point that you really need to be aware of, and actually I'm going to do cost, I'm going to color code this here. So let's see, here's your cost function, which is green. And the revenue function, which is blue. Okay, so which point, A, B, or C, represents the fixed costs? What do you think?
Is it B?
It is B, yeah, right? But these are lines. And the y-intercept will be the initial cost, right? Or the fixed cost. This would be point B. Right? So if this cost function is a line, it has y equals mx plus b, where this is your initial value. That's also true, when you have exponential graphs, right? The y-intercept will always be your initial value. Okay. So this is point B. Okay, now describe what happens at quantity I, and I, or 1, 2, and 3. So at I, what we have is cost is greater than revenue, right? At that quantity. So if the costs are greater than the revenue, what happens to the company?
They're losing money.
Yeah, exactly. Very good, Sophia. So the company loses money. Now, at II, or 2, if you look at this quantity, what's happening?
It's the break-even point.
Yes,
The 0 profit.
right. So C, cost equal revenue. So the manufacturer or the company breaks even. And then, of course, at that last point, we like that last point. Here we've got revenue is greater than cost. So revenue is greater than cost, company makes money or makes a profit.
I have a question.
Yeah, go ahead, Kevin.
So when it says,
Face first.
I don't know what, oh. Okay. When it says which point represents the fixed cost, is that always going to be, like, is the answer to that always going to be the break-even point, or?
No, the point that represents fixed cost, here's your cost, right?
Yeah.
So it's got to be a point on the cost, and it's always going to be the y-intercept point.
Oh, okay, I see what you're saying. All right.
Okay, good. Yeah, I'm glad I clarified that. Yeah, that's really important that you guys know that. Okay, so it says find the equilibrium price and quantity if a quantity supplied is that 3p minus 50 and the quantity demanded is 100 minus 2p. So we want the equilibrium price, which is where the companies break even, right? So what am I going to do?
Aren't you gonna set them equal to each other?
Yeah, absolutely, James. Thank you. So we'll just take
Sean.
What's that?
Yeah, it was Sean. I'm not James.
Oh, I'm sorry. James is right underneath you. Sorry.
No, it's okay. Don't worry.
Thank you, Sean. It is nice to get to know your names because your names show up right under your face, which is why I want to get to know, I want you to show me your face so that when we go back face to face, I'll know who you are. But you're not going to be wearing your name tags anymore, But sorry about that. Yeah. Thank you, James, for putting that on. Grady, I'm missing your face. Come on. This is to help me. 100 minus 2p. So let's see, if we add this, you'll get 5p, add 2p to both sides, 5p minus 50. This is simple linear, right? 5p is equal to 150, or p is equal to $30. All right, so I've got that. How am I going to find the quantity? Here's your hint.
You plug 30 into any of the equations. You plug it into P for any.
Yeah, very good. You could plug it into either equation. It doesn't matter. right? Because this is quantity, right? So you could say quantity is equal to 3p minus 50. And when p is equal to 30, you have Q equals 90 minus 50 or 40 quantity. So the equilibrium price occurs when the quantity supplied is equal to the quantity demanded. Okay, so you can go back and redo problems from homework. You can use your notes. You can use this. I would work on getting your 3x5 index card together. And then I would study using all of that stuff. And then if you run into some issues, that's when you call out and say, Miss A, I'm having trouble with this concept. Can you help me with this? Okay. Giselle, do you have a question, honey?
Yeah, when is the test?
The test is, and this is on the Loyola Moodle. All of this information is on there, right? Matter of fact, let's go there so that people don't ask me that question. They can just look it up. Where is it here? So what do we have here? Course pacing guide. So here, let's see, here we are at February 17th. What we're going to do is, since we're not face-to-face next Monday, I'm going to just go ahead with the next chapter, but your chapter 1 test will occur February 24th. Okay, so our test is not next class, which should give you a little bit of extra time to study. Any other questions? Thanks for asking that question, Jadelle.
Are we just doing like the notes for 2.1 and 2.2 on Monday?
That's correct.
Okay.
Yeah, and then let's see, Wednesday is February 24th. So your homework for this is not due until 2 days after you take the test. So that should give you enough time, don't you think? Yeah. And honestly, guys, if you ever think like, hey, Miss A, I think there's not enough time to do what you're asking us, I'm pretty lenient on that kind of thing. I mean, if you have a point, I'll be like, yeah, you're right, I'm gonna change that date. Any other questions for me? All right, go study. Figure out what you're going to put on that 3x5 card, and I will see you guys Monday online. And then next Wednesday, we will be face-to-face.
Thank you.
All right, you're welcome. You guys have a great day.
Thank you. Have a good day.
You're welcome. See ya.
Thank you.
Yeah, Giselle,
I
I'm
actually
not
have a
going
question.
anywhere.
Okay, so I'm remote. So how will that work?
And
For like
Tom
what?
is too, right? Isn't that your question, Tom? Okay. Matt, do you have a question?
Yeah, when is the homework for 1819 due on Wiley Plus?
It said tonight by 11:45.
Okay.
Yeah, I think I changed it, right? Tonight, yeah, at 11:45. Okay,
So it's due tonight?
yes.
All right, cool. Thank you.
You're
Have a good
welcome,
one.
Matt. Thanks, you too. All right, so for you two, this is what we're gonna do. I'm going to send you both by email the test. And you guys are going to print it out. You both have an ability to print it?
I do not actually.
How do you do with your classes if you don't have a printer, Tom?
I just do them all online.
Okay, and Jadelle, do you don't have a printer either?
I have a printer.
Okay, you know what I can do is I can give it to you on Wiley because that's where the questions are going to come from anyway. So I'll just make both of yours digital on Wiley. But what you're gonna have to do is you're gonna have to use scrap paper. I need to see all of your work for every problem. And I'm serious about this, okay? You can't just answer it or guess. I wanna see your work. And then you take pictures of your work, make sure it's nice and neat, and then you email that to me as soon as the time's up for the test. But you guys still show up online. I'll put you guys up. I'll be in the classroom. And we'll do it that way. Does that sound reasonable?
Sounds fine by me.
Okay, and you can both still use a 3x5 card, okay? And you please don't try and use all the notes because you're gonna run out of time if you do that. Okay, just use a 3x5 card. Trust me, I did this last year online and some people ran out of time because they just thought, well, I'll just peruse through my notes. You just don't have time to do that. You need to know it ahead of time. Okay, guys? Does
Okay.
that sounds like a plan?
Yeah.
Sounds good.
All right, awesome.
All right. Thank you
I'll see
very
you
much.
guys. You're welcome, guys. I'll see you next class.
I have
See
another
ya.
question.
Have a good day.
Okay, you too. Go ahead, Jadelle.
So I kind of missed the part when you were speaking of the 3x5 index cards. Is that mostly just like writing down things that we need to study? Or is there like a specific thing you want us to do?
No, this is totally for you. Okay,
Okay.
you get to bring into the test a 3x5 card. So whatever you think you need to put on that card is totally up to you. But as you study, as you like try problems, you'll be like, oh, I need to put that on my card because I always forget that or something, you know?
Yeah. So what would you like recommend other than like the flashcards to like for studying?
What would I recommend that you put on it?
No, like what do you recommend like other than like flashcards, like another step to like
Oh,
study?
you mean a way for you to study?
Yeah.
Well, this is what I always did, and it always worked really well for me.
Okay.
I would group things into like maybe concepts. So I start out with a big flashcard where I would rewrite my notes and try and relate things in my mind. Okay, this is kind of like this, and put those on the same flashcard. And eventually you get to smaller and smaller flashcards because you know something, right? And you're synthesizing stuff in your brain. So start with big things, right? I used to just rewrite my notes on a big card and try and relate it. You know, not rewrite everything, but do diagrams and say this is like this or whatever, just try and make connections. And then the more you do that, the better, your brain is going to be taking stuff in. And so you'll look at a flashcard and you'll go, I know this. The only part of this that I have trouble with is remembering the formula. So I'm going to write the formula, right? And then on the card, that kind of thing, So start out big and then work your way down and you'll be good. And then and you'll be learning it in the process.
Okay. Thank you.
You're welcome, sweetheart. Hey, if you run into issues, you can just call me, right?
Yeah, I will.
All right, cool. All right, sweetie.
See ya.
All right, have a great day.
You too.
Thank you.